Hello, guys, so today we are going to create underwater bubbles. We will use curve force and smoke advection to derive the movement of the sphere. Take a sphere node. Set the primitive type to the polygon. Set the radius to 1 along all axes. Set the x-center value to 1. Increase the frequency to 4. This will be our source geometry. Now we need to give some animation to it. Take a transform node. In the transformation of the z-axis, write this. Since my timeline starts from 1001, that's why I'm negating the value from 1000. Now in the rotation of the z-axis, write this. Take another transform node. Now in the x-axis of the translation, write the same value from above. In the rotation, write $fx2. Now the animation will look something like this. Add a null node and name it out_anim. Take a pack node. Turn on the path attribute. Now if you middle mouse and see we have only one point. Take an add node and turn on delete geometry but keep points. Take a solver node and dive inside it. Take a merge node and merge the previous frame and input 0 node. If you run the sim, you can see we get the trail path of our sphere animation. Again, take add node. Go to the polygon tab and then go to the by group tab. If you zoom in and see, now we have a curve. Now take a timeshift node and freeze it to the last frame. Take a resample node to reduce the point count on the curve. Keep the length value around 0.77. Add a smooth node to remove some hard edges. Now again, take a sphere node. Change the primitive type to the polygon. Set the radius to 1 along all axes. Take a scatter node. Set the force total count to 6. Now we have 6 points here. I have an OTL which was developed by my friend Henry. This OTL copies the curve in the given source points while adding some noise to it. I will give a link for Patreon. You can download the OTL from there, it will be free for everyone. Connect the scattered points to the first input of curve noise. In the second input, connect the curve. As you can see, we have 6 curves. Turn on Enable Profile button. Go to the Twist tab and turn on Enable Twist. Set the global twist angle to 350. This parameter will twist the curve. You can also play with the ramp to blend the twist value. Go to the Noise tab and turn on Enable Noise. Set the global noise to 5. This parameter will add some 3D noise. You can also play with the ramp to give some offset along the curve. Take an attribute delete and delete the CD attribute. Now we need to calculate the velocity. Take a polyframe node. In the tangent name, write V. Take an attribute wrangle and write this code. We are just negating the velocity. Take a point from volume node. Set the value of the jitter seed and jitter scale to 1. Take a pyro source node. In the Initialize menu select Smoke. Set the density and temperature scale value to 1.2. Now take an attribute noise node. We need to use an older version of attribute noise. To switch back to the older version, go to Assets, Assets Manager, Configuration, Assets Definition, Toolbar. Change the signature to 1D. In the attribute select Temperature and Density. Turn on Animated and Remap Noise. Set the minimum value to -1.2. Set the maximum to 1.2. Adjust the ramp to something like this. Set the element size to 0.94 and the fractal to none. Now take a volume rasterize attribute. In the attribute select Density and Temperature. Remove Density from the Coverage attribute and turn on Normalize by clamped coverage. Take a DOP network. Let's create a basic pyro setup. In the gas resize field, turn off clamp to maximum. Increase the padding value to 0.4. In the source smoke, set the input to the first context geometry. In the Initialize menu select Smoke. If you preview, you can see the smoke is going downward, but we need to lift it up. Go to the Pyro Solver. Set the temperature diffusion to 0.36. This parameter helps to blur the temperature field. Set the cooling rate to 0.6. This parameter decide how fast the temperature will cool down. Go to Combustion and turn off Enable Combustion. This tab is mainly used for creating explosions. Go to the Shape tab and reduce the dissipation value to 0.07. Turn on Disturbance and set the value to 0.385. Turn on Turbulence and set the value to 0.25. In the Dissipation, set the maximum control range to 2. Now go to the Disturbance tab and set the block size to 0.27. Turn on Use Control Field and write the temperature in the control field. Increase the control influence to 1. Reduce the maximum control range value to 0.05. Go to the Turbulence tab. Increase the swirl size to 1.35. Increase the turbulence value to 3. Set the value of control influence to 1. The smoke is still going in the downward direction. To fix this, go to the Advanced tab and remove gravity from the scale forced. Cool. Now let's reduce the division size and cache it to disk. We need only density and velocity. You can delete the others field. Take a trail node and connect to out_enim null. Set the result type to compute velocity. Take a color node and set the color to black. After that, take an attribute paint node and paint some random patches. Take a scatter node. Turn on the density attribute and right mask. Turn off relax iterations. Take an attribute delete node and delete the color attribute. Take an attribute wrangle node and write this code. This code will calculate the length of the velocity and it will delete the points whose velocity is less than the given threshold. Take a pop network. Connect the wrangle to the first input of the DOP. In the second input, connect the smoke cache. In the third input, connect the curve. You can add null to all the sources, for a cleaner network. Go inside the popnet. Select points in the emission type. In the geometry source, select the first context of geometry. Go to the birth tab. In the impulse activation, write $f equals 1008. Copy the same expression and paste it in constant activations. Reduce the constant birth rate to 2500. Go to the attribute tab and reduce the inherited velocity to 0.65. Take a pop force. Set the amplitude to 0.6. Now take a pop to advect by volume. In the velocity source, select the second context of geometry. In the activation, write this. $f greater than equals 1020. Take a pop curve force node. In the geometry source, select the third context of geometry. You can turn off the guides. Take a pop force node. Set the y-axis force value to 2. Go to Pop Solver and reduce the timescale to 0.7. Go to Collision Behavior and turn off Add Hit Attributes. Take an attribute wrangle node and write this code. So here in the Vex, first we are going to select randomly based on the ID attribute whose p-scale will be bigger as compared to the normal points. We are creating a parameter where we can set the size of the bigger particles. After that, we are creating the p-scale attribute. We are also reducing the velocity. This will reduce the motion blur amount in rendering. Now again take a sphere node. Change the primitive type to the polygon. Set the radius to 1 along all axes. Take a copy to the point node and let's copy the sphere to the simulated points. Take an attribute VOP node. We need to add turbulence noise to our current position. Adjust the noise value according to your need. Set signature to 3D on the turbulence noise. Thank you for watching. Make sure to hit the like and subscribe buttons. You can also support me on Patreon.